All right, so to lead into our next, technique that we're going to see, you've noticed this is part two. I guess technically it's part three at this stage. That's going to bug me. So yeah, there we go. Back to the movies, part three. So I've kept coming back to this well of doing this Cary Grant movie marathon. So at first we had 720 ways we could show the movies in question. There were 6 of them, as a reminder. Then we found out we can only show 4. That cut things down, and it turned out that using like our methods for counting permutations of objects, we were down to 360 marathons. So the last thing I want to do is I'm going to take us back in time temporarily. So pretend that it's like 2005 or something like that. And in order to run this marathon, we actually need like physical media for these, movies. We've got to go like get some DVDs in order to show the stuff for this marathon. We're not just going to stream these off like, Netflix or, whatever. So we've got to send somebody to the video store. So they drive down to the Blockbuster. If you don't remember what Blockbuster is, it's okay. But we send somebody there, and they've got to rent the movies for us to show for the marathon. We'll pretend for a moment that Professor Carroll doesn't already have all of the movies we use, like, in another room. But whatever. So we send our person. They need to pick out 4 movies from our list. Now, obviously, we've hashed this out with them, but maybe we don't 100% trust them. They get back with their Blockbuster bag, and then we say, well, what'd you get? What'd you get? Did you get what you were supposed to get? And there's a lot of hubbub there. And you might end up wondering at this point, well, what exactly would be the difference between what we've just said and what's going to happen when it's actually time to show the movies? Well, there's one big difference that ends up coming up here. So, for what it's worth, do we really care about the order that the movies are in the bag? I wouldn't. I can't speak to you, but as opposed to when we're showing the movies, we really want, maybe we really want our favorite to come first, or we want it in the last spot because we think that's the most important or something. But as far as where the movies are in the bag, we don't really care. So long as the ones that we're supposed to get chosen are in the bag, we're probably happy. So in this instance where the order of selection doesn't make a difference, instead of counting permutations of objects, because that very specifically preserved the order of things, what was coming first, second, third, you saw that previously, we can do what we call counting combinations of objects. So again, there's a formula for it in the PowerPoint slides. I have no expectation that you're going to use that formula. It looks an awful lot similar to the permutation formula if you go dig into it. The big thing is it actually has an extra thing built into it specifically to factor out, the order of the objects in question. So when the order of selection does not make a difference to us, we can count combinations instead of permutations. So for our particular example here, so we had 6 movies. We've got to pick 4. If we don't care about the order they're in, like I said, all we care about is are the movies that Freddie or whomever was supposed to get out of the at the video store, are they actually in there? We can count 6C4. I may slip and say 6 choose 4. Just a word of warning. Now, for what it's worth, I'm not going to try to replicate the awkward Professor Carroll spends like a minute and a half trying to hold his calculator in front of the camera appropriately. It's in that same menu that we've been talking about. You probably already noticed it, like between the permutation, command and the factorial thing that I've already observed. So the same type of formatting that we've done before, 6, NCR4 in my calculator. If I work that out, there are 15 different ways that our person could have picked out 4 of the 6 movies we wanted from the video store, in terms of how they're in the bag right there. So that's one example here. One thing I do want to point out before we take a look, and you may be shocked, I'm finally going to come up with something that's new and not just me talking about horses or, the president of dance again or what have you. So all of the stuff that we've done up until now, you could technically get by without all of those formulas. We didn't really need factorials for the counting stuff we were doing or counting permutations. They sped things up, but they weren't necessary because we could always fall back on arranging things using the fundamental counting principle. Combination counting problems, technically you could do it, but it's kind of a pain. So no, really using the NCR formula, or the command on your calculator to count combinations is a more efficient way to go about this. All right, I promised you a new example. Here it is. So we've got a guy named Lucas. Lucas has what I consider to be a lot of children. I mean, maybe you come from a really big family and this is not all that abnormal, but I've never known anybody who has 9 children. So anyway, so he has many children. He's got to go run an errand. He's taking some of the kids with him in the car. So this is a big stretch, but we're going to assume for the moment that these kids aren't going to argue over who gets to sit where, like the window seats versus being like in the middle of the back or what have you. So he's got very agreeable children, which is good. So in this instance, if the order in which the kids are sitting in the car doesn't matter, well, he's got 9, as you can see, he's got 9 kids to choose from. He's going to pick 3. So we have 9C3. Again, I did some number crunching before I turned on the camera, and I ended up getting that Lucas has 84 different ways, to pick kids. So yeah. So that's, so if he's trying to set up like a chart, he's got a lot of rows he's going to have to fill out in terms of how he's going to have these things arranged. So yeah, that's, as I said, that's what's going on in this instance. So you may end up wondering at this point, well, we have this thing for counting combinations and this thing for counting permutations. How do we decide which to use? Yeah, so we've got permutations, we've got combinations. Which one do we need for a given problem? As it turns out, you can distill this down to one. That's right, one question that tells you whether you want to count permutations and use NPR or combinations and use NCR. That big question is, does the order in which we make our selections, matter to us? So, as we said before, with the people picking the president and vice president, they might really want somebody as president as opposed to VP, or we really care about who's got a movie coming, which movie plays first in our order. So you can sort of flowchart this. So if your order does in fact matter to you, so you can imagine this if you think of things in a bag, you're like clicking them out one at a time. So you notice which comes first and second, and on down to last. So in that instance, you want to count permutations if we care about the order. So on the other hand, if the order of selection doesn't matter, so I usually think about this again in terms of things in a bag. If you're just going to scoop them all out at once and just plop them on a table, then you don't care what came first or not. But if the order doesn't make a difference, you want to count combinations instead. So that gives you kind of an easy, a relatively direct kind of flowchart way to determine which of these formulas that you want to use. Okay, so let's take a look at another example real quick. All right, so here's the setup for this example. So, imagine a class, that I can't recall how long ago I got this. This is not representing our current course. But anyway, so we have 27 students on roll in the class. 20 of them are listed in self-service as first-year students. The other 7 have been, at Mars Hill for a while. So, and the course instructor, which, was me, I didn't actually do this, but it works for an example. I was going to pick out 4 students from the class for, some kind of group project. All right, so here's my setup. If I wanted to take a look at this, I got a few questions, like, how many different ways could I pick out a group regardless of how it's actually composed? Like, I don't care if it's 4 returning students, 4 first years, or what have you. So if we had an overall count of the number of groups, so at this point, I don't even really need this separation. I just have 27 students, and of those 27, I want to pick out 4. So we have a 27 here, I have a 4 right here. So I haven't filled in the letter in the middle. So coming back, do we care about the order in which the students are chosen here? Not really, because I haven't specified like one person has to do like an oral presentation, the other has to like type up the paper or anything like that. All you're going to care about is if I've got like names in a hat, have I pulled out your name or not? It doesn't make a difference whether it's first or last. So in this case, since the order doesn't matter, I want to count combinations. All right. So now I worked this out. 27C4, as it turns out, is a pretty big number. So we have 17,550 ways I could pick out 4 students from this class, regardless of whether or not they're seniors, first year students or what have you. So I want to take a look at one more example along these lines, and then we'll press pause. How likely is it in this instance that we only have first year students in our group? So at this point, now we really don't need the 7 returning students. I'm going to pick out four people, but they all have to come from this part of the pool. So these guys are kind of gone, and as such, we have 20 C4 instead of 27 C4. So that's going to change the parameters a bit. As it turns out, when I worked this out, 20 C4 in my favorite calculating device gave me 4,845 different groups that could consist only of first-year students. All right, so I think that's where I'm going to draw this video to a close. I've got one more example related to this group choosing thing for the class, but I think it'll work well kicking off our next video.